morning. Thank you for the time. My name is Deri Pramono Adi, and I will present our research paper entitled Boosting the Accuracy of Stock Market Prediction Using XGBoost and Long Short-Term Memory. Our agenda is disclosed as three parts. First part is brief introduction of stock market and the need to predict the stock market prices, and then our research question. Second part is the application of long short-term memory and extreme gradient boosting as the two deep learning methods that we use in our experiment, and how would we use them. The third part is the result with our work comparison to the previous work. Let's start with background and hypothesis. We know that many people have played around the area of stock market. It's easy, it's simple, and it's doable in our house. The strategy is quite simple and beneficial. So you just buy stock when the price is low and sell stock when the price is higher. So naturally, people have tried many different ways to predict prices that would be beneficial for them, when to buy and when to sell, but just using intuition. While it should be analytical and sometimes using the statistics based methods. There are technical analysis method, which is an analysis method for forecasting the direction of prices through the study of past market data, primarily price and volume. So we, as people, as human, we have so huge human error, so we cannot compute or count or forecast this past market data into predicting the prices. So we need a machine. So are there any robust machine learning methods that can yield high accuracy value? And if so, if anybody has done it, can we boost it into higher value? Second part, methodology. In this part, in our experiment, we use two methods of machine learning that is robust and famously known for years. The first one is XGBoost or Extreme Gradient Boosting, LSTM or Long Short Term Memory, and the last we use features and data from IDX or Indonesia Data Stock Exchange, while features included are minimum and maximum price, open and close price, and volumes. Standard features that are needed for technical analysis. So what is XGBoost? Gradient boosting is a weak classifier conversion process to a much stronger classifier. This process is repeated according to the needs of the desired model, which in this case is the stock market prediction or forecasting. The boosting terms is in line with the engineering goal to max out the boosted tree algorithm's performance from the computational resources, even to boost its limit. The second method is the LSTM algorithm. The LSTM algorithm is famously known and capable of handling the learning process on time series based forecasts for a fairly long-term dependencies, whether it's backward or upward. It also works best with large type of problems. In general, LSTM is augmented by the forget gates. These gates is controlled as any error can be backpropagated through any number of layers. Such mechanism enables LSTM to learn from previous steps and error and mistakes in so for reducing error effectively. Here are a little bit illustration of forecasting. We use the recursive forecasting as the block diagram here shows. From the illustration, the iteration is represented by epochs in respective machine learning methods in LSTM and its XGBoost. Third part is the result. So now throughout the year, the implementation of LSTM and XGBoost are sought for stock market prediction. Naturally, LSTM is benefited because it is for the time series based data, which is the stock market data is. While XGBoost is a robust tree-based algorithm that outperforms sometimes SVM and even the predecessor of LSTM, recurrent neural network. Many applied LSTM and XGBoost into their work. The table here shows some of the fellow researchers that also using XGBoost and LSTM for stock market prediction. The highest accuracy value for XGBoost is achieved by Basak and the team in 2019 by 94.79%. For LSTM, is achieved by Rondiwala and team in 2017, bearing accuracy value for 99.92%. In 2020, our experiment for XGBoost, we yield 99% of accuracy value and 99.995% for LSTM. That's 0.005 loss for LSTM, considerably a small percentage loss value. And to add, we only use 10 epochs for LSTM, while for XGBoost we only use 25 epochs. So LSTM once again proved their worth in the case of time series data. In the future, we set to believe in using various number of other technical features to provide much more real and detailed insight to both data and result. Furthermore, another machine learning algorithm with more rules and multiple features possessed can be employed in order to yield beneficial information to the traders. That ends our presentation today. Thank you for attending our research paper presentation.